All right, good day, everyone. This is Jason Straight with the PaaS Cloud Virtual Group. Our presenter that we have here today is Roberto Cacalcanti. Hopefully I got that right. I forgot to ask
that right. Yes.
Forgot to ask you about that right before we started here. Our presentation today is Azure SQL Managed Instance, Lessons Learned from the Trenches. Since this is something I'm actually bringing into where I'm at right now, this is something that's going to be very useful for myself. Before we get started, just wanted to mention that our virtual group is sponsored by Microsoft Azure. They're helping to sponsor this group to make sure that we can continue to have these go-to webinars, and that gives us the opportunity to have a lot of sessions. And speaking of the number of sessions, actually, I'll speak about those in a second. I forgot I have this one first. If you aren't currently on our newsletter for the virtual group, I do recommend doing so. You can just go out to cloud.paas.org and log in there to subscribe into the virtual group, and that will get you the newsletter. And the reason why the newsletter is important, and this ties back into our sponsorship, is that we have a lot of upcoming sessions. So I've got 15 of the upcoming sessions listed right now, and I've got about 7 of them that I didn't include in that just because it makes the print so tiny. So there are a lot of upcoming sessions. We have almost 2 a week going all the way through January. So lots of opportunities to continue to learn about building data platforms in the cloud. I am still looking for more presenters. I mentioned that we've got about 24, 25 sessions that are scheduled. Tuesdays and Thursdays all the way through the end of March opens up about 56 possible sessions. So if you are interested in presenting, there are lots of opportunities. If you want to, you can, on the last screen, you can click on our call for presenters, or you can email me and I can get you out onto the schedule. Coming up this fall is the Virtual PaaS Summit 2020. If you've not yet registered, you can get $50 knocked off of the registration fee by using the virtual discount code for our virtual group. That's the code that's right there on the screen. If you do miss it and you want me to throw it in the chat, just let me know and I can give that to you as well. This virtual group is part of a number of virtual groups that PaaS helps to support. Some of them focus on different languages like Global Chinese and Global Spanish. Others focus on different areas of technology like high availability disaster recovery and PowerShell. If you are looking for other ways to learn about building data platforms, there's lots of opportunities there. Throughout the session, I'm sure some of you will have some questions, and if you do, please type them into the question panel. At the end of the session, time permitting, we will go through as many of the questions as we can. So at this point, I'm going to hand things over to Roberto for his session today, Azure SQL Managed Instance, Lessons Learned from the Trenches.
Thank you very much, Jason. It's great to be here. I will show my screen now. Let me know if you can see my Azure Data Studio.
Yep, I can see it.
Excellent, thank you. So today, I just wanted to start presenting myself. For those of you who don't know me, my name is Roberto Cacalcanti. I'm part of a team of architects and engineers in Microsoft called CAE, Customer Architecture and Engineering Team. And in my previous roles with Microsoft, I worked as a support escalation engineer for Azure SQL Database, Managed Instance. And then I became a Premier Field Engineer, nowadays called Customer Engineers, also supporting customers with managed instances and Azure SQL databases. And those lessons that I learned throughout those years supporting customers, I put together a series of learnings, and that's what I'm presenting to you today. I've been teaching this and showing this presentation to internal teams, and now I'm also expanding to external to Microsoft. So what I wanted to cover with you today is mostly performance related. There are multiple areas in Azure SQL Database Managed Instance, but performance is where I've been focusing on, and that's what I want to give you more details. This presentation doesn't have slides. It's going to be all demo based, and let's get right to it. I will cover some of the objectives and also how we are going to accomplish those objectives. So there are multiple reasons why you would have performance problems in SQL MI. It's very similar to how you may see it happening in SQL Server or in Oracle, Postgres, MySQL. Those are common issues that you find happening as you use a relational database. In today's presentation specifically, I'm going to speak to both experienced DBAs who are looking to adjust their skills to SQL MI, and also for those of you who are newer DBAs who are starting your career already as a cloud DBA. There's another group of professionals who may also benefit from this presentation, who are developers who maybe for some reason ended up inheriting or recently been given a cloud DBA role. That was quite common in the beginning of SQL DB and MI usage 5-6 years ago. Not MI is newer, but SQL DB, a lot of developers got thrown into this role of being a DBA because smaller companies didn't think they needed DBAs and just threw that at them. So maybe that's you. This is a short 1-hour presentation, actually 40-45 minutes. And then if you need for just more details about the specific topics that I'll be covering here, feel free to contact me. You have my details, my contact details later on, and just send me an email. I'll be glad to point you to anything else that can help you with the content we're covering today. For example, I'll talk about KQL queries. These are queries that I use to troubleshoot performance issues in Azure MI. But if you're not familiar with KQL, the Custo query language, just contact me and I'll point you to my GitHub KQL queries or to a KQL training, documentation, anything you need. So again, feel free to contact me. My goal after you watch this presentation will be for you to have a better understanding of how to troubleshoot and monitor SQL MI queries, specifically for performance issues. And I want to show you the tools that are at your disposal, such as the query store, extended events, DMVs, log analytics with KQL. So one important thing that I want to call your attention to, most of the techniques that you already know from your previous experience with SQL Server performance troubleshooting, or the multitude of trainings and videos that you find out there, blogs, documentation from performance tuning gurus, these also apply here. Most of them apply here. So if you want to see if whatever you already know for SQL Server performance would work in MI, give it a try. Most likely it will. So today we'll focus a little bit more on the different stuff, what you have in SQL DB and what you have in SQL Server that you cannot use here and what you can use here. So I'll mostly do demos with this notebook that you see in front of you and the portal to show you how I teach my customers to troubleshoot for performance in a different way than you generally do with SQL Server or even SQL database, for those of you who are already familiar with SQL database. And some of the tools that are awesome in SQL DB are still not present here. Okay, so I will cover two main paths. One is just identifying a problematic query, which typically it will be a query that's consuming the highest amount of system resources. And then I will retrieve the query execution plan to see what's going on with it. If this query is performing poorly consistently, then it may be for different issues. It could be hardware constraints. In MI, you have hardware constraints as well. It could be a suboptimal query structure, how you wrote the query. It could be a database compatibility setting. In MI, we have up to compatibility 150, which is the same as SQL Server 2019. By the way, there are tons of awesome performance improvements that you have in compatibility 150, that if you turn your managed instance database into that compat level 150, you will see immediately some types of performance issues going away. So here's my first tip. Try and use 150 as much as possible. Another kind of issue that you may find is missing indexes, or maybe the query optimizer chose a bad query plan. So same as SQL Server, right? Same ideas. The second scenario that I wanted to cover with you today is when a query that has a good plan, that's been performing well, it's just consuming a lot of resources. And you may see that it's quite easy to pinpoint those with the tools that I'll show you. But it may be just bad. You won't believe it, but well, maybe you will believe it. Most of the issues that we see in query performance in our support organization, I mean a high number, it's just because statistics are outdated. And we have plenty of cases where customers know that they need to update statistics. And if you don't know, if you're listening to me now, you don't know what statistics are, that's a very important topic for you to study and learn and get more acquainted with, because SQL still depends a lot of it. Now, in 150, we've done some improvements in the query optimizer where it's much more forgiving, but you will still need to keep up with your statistics updates. So I was mentioning one of the most common scenarios that we see is that statistics are outdated and queries are performing bad. And we just asked the customer, could you please go ahead and update stats? And sometimes we have reluctant customers who say, but I just did it yesterday. It's on my weekly update schedule. Well, there are some scenarios, and they kind of are constant with the people that call us, where maybe you had this huge ETL load that just skewed the data, and now the query optimizer just doesn't get an appropriate execution plan, and you're gonna get performance issues. So another tip that I've learned from these engagements, update stats, just see what's going on. Now, I know it's easier said than done, because there are many times when you have huge databases. I would say anything over a terabyte would be hard to just, well, just update this table. It's harder than said than done. But you know your database, you know your workloads, see what you can do to update stats, maybe just using a sample, anything you can do to help the optimizer, especially if you're not on 150. Okay, so let's get to this notebook that you see here on my Azure Data Studio. You probably noticed that many folks inside of Microsoft have been using more and more notebooks instead of SSMS for our presentations. And I've been getting this question over and over since I started doing this. Why isn't SSMS better to work with MI than Azure Data Studio? It depends. This tool has come a long way. It's not a replacement right now. There are many things that you still do in SSMS, but for presenting, for the easiness of showing you different font types and sizes, that's mostly why many of us are doing this. So anything that I'm doing here, or most of the things that I'm doing here, you can just do in SSMS. And I'll be going back and forth to both of them so you see the differences as well. Let's look at these initial steps. I'm dealing with two scenarios. One, something happened yesterday, and at 10 p.m., I got a call. I'm the DBA. I got a call from my operations folks saying, or from the folks who were dealing with my application, the company's application, that everything was slow and outside of the norm, and they got these alerts showing them that the database was the fault. Of course, the database is the culprit. And then I'm the DBA, and I want to see what happened last night to try and understand. Let's say I'm not the DBA who was on call, so I didn't get that call last night. I am just today looking at what happened last night that all of a sudden got resolved, but there was that degradation in performance. And let's look at what's going on. So there are DMVs that you can do this. And then the other scenario, so sorry, I didn't tell you the other scenario. The other scenario is it's happening right now. What can we do to see what's going on right now? So let's look at those two scenarios. What happened last night and what's going on right now. So if I want to look at what's going on, the first thing I do is to verify consumption. In Azure SQL Managed Instance, we have this DMV called DM User DB Resource Governance Internal that will show me the details about the server. So if I run it here, it will give me this information that's telling me that I'm running a managed instance of the type general purpose. And if you don't know what that is, general purpose versus business critical, you will see on the resources that I'll share later all the details about it. And it tells me that it's a 4-core machine. So I know that nothing changed with my server. It's still the same server that I've been working. But if all of a sudden I see here that it has more CPUs, or it's instead of being a general purpose, it's a business critical, then I can immediately take other actions, such as, hold on, this is costing too much, let me bring back to whatever I need at this point. So that's the first step. You see that this DMV, I put a star over here. I hope you can see this. I hope it's not too small, but my Zoom it is not working here. If it is too small, please let me know. So on this DMV, there are tons of details about this machine in this server. So if you scroll through the many columns that there are here, there are some that will tell you, for example, the max number of sessions. So I'll give you an example of a customer that I worked with, and they had this television show that people were calling them to vote on. It was a show just like, American Got Talent, and someone performed, and then the viewers would call and vote for such and such or another one. And then all of a sudden they went over at their MI, I believe it was only 3,000 sessions. I don't remember the number. My MI here allows you to have 30,000 sessions. And the amount of people who were just calling them at that time was over that number, the maximum number allowed for that MI. Therefore, the sessions were just not going through. They were being canceled. And we ended up working with our product group. I talked with our developers. They helped that customer to increase the number of sessions for that specific managed instance. But that's one thing that you may see, and you see an error. It's a performance related error, but it's really just you are going beyond the maximum number of sessions. And same thing with workers, and you see a lot of this information, a lot of useful information in this DMV. The other DMV that MI offers you is SysDM DB resource stats. This is super important. Same thing for Azure SQL database. You don't have that in SQL Server. When you run this query, it tells you how much CPU, how much data I/O, how much log writes are being used. And you can see this information. Let me just go back here. You look for I/O reads, I/O writes, close to 100% of them you need to worry about because of throttling. If this gets to 100%, your performance will go down right away. Nothing's gonna happen anymore. Only the queries that are getting that CPU time are running. A bunch of others will just stack up. So you have SPIDs just waiting and waiting and waiting for CPU. Similar to when you have in SQL Server, you reach the maximum CPU capacity, and you have the scheduler wait type. Just you can't get CPU time. This is similar, but here, instead of getting a little quantum and just preemptively getting more cycles, here that's not going to happen. In MI, the session will just pile up, and that's going to be very bad for your performance, your application performance. Therefore, this is a very important DMV for you to pay attention to and look at. You can do the same. I just went up again, because from this point on, there are many variables that would cause that to happen. So instead of giving you a prescriptive how to do it, just one scenario, I'll show you various scenarios. And the other way of looking at this information is going to the portal, and under metrics on your SQL MI, you will get this kind of graph that can show you the exact time as well visually on when you were having high CPU percentage. This graph, differently from SQL database, offers you, if I add another metric, in SQL database, I can see IO percentage, read percentage, write percentage. Here, I have bytes instead of percentage. Therefore, when I add, the scale is just different, and I can't correlate like I can do with Azure SQL database. Therefore, these metrics here, use it in SQL DB, but for SQL MI, not as much. So let me remove this and go back to the CPU. Excellent for CPU alone. And you can modify for the last 30 minutes to see what's going on, or you can see what was going on yesterday. So let's look at the last 24 hours, where at 6:52 a.m. there was this peak, and you need to see what's going on. Now, you can see that you can change it to UTC or local time. If I apply UTC, it should change, but for some reason, my portal is not changing data, the dates, the times. So it's only showing me, I believe this is UTC, it's not local. But generally, you can see it's probably some bug that's going on with my portal. I have a preview portal inside of Microsoft, in your portal, you may not have this issue. I'm a tester for our internal portal, so I find bugs and I report them. So this is probably one of them. But in normal conditions, you should see local. When you apply local, you should see local time. And this is very important for you to identify when the issue happened exactly and look in the past. Okay, so going back to my notebook, this is for right now. The portal can be for right now and it can be for the past. So going down a little bit, another tool that I wanted to show you, also using DMVs, is this query performance insights that our managed instance product group put together. And I have the link there. You have access to my notebook. I'll share it with you. And the link points to this site where we have here the entries from Jovan Popovic, where you can use this tool that encapsulates MI DMVs, a number of DMVs in a easier format. So if you want to see, for example, what are the queries that are running right now, you could use regular SQL Server DMVs. So query stats, or you could run a DMV like this one. So let me run this, and you can see what are the queries that are running at this moment. So let me kick in another query using OStress, and let's see if it shows here. There we go. Now we have one more running. So instead of knowing all the details about your SQL Server DMVs, we have this library that you install that encapsulates a lot of the DMVs together and gives them names like blocked queries, query locks, what are the active backups going on, what's the CPU and memory of this server. There's this other one that shows you the stats, the file stats. So it takes a snapshot of the file stats DMV. You run some workload. Then when you run this again, you see the differences. It gives you the deltas. So it makes it much easier to troubleshoot performance. Same thing with weight stats. So if I had some weights, if I run this and then I run my query, when I run the weight stats, it shows me the delta, the differences between now and back then. Excellent way of troubleshooting performance as well. Another tool that I want to show you back in the portal, by the way, to install QPI, it's very simple. You just go to the page that I pointed you to. You click on SQL Managed Instance, but if you have SQLDB or SQL Server, you can also use the versions for them. It takes you to this raw page where you copy and paste this to your Management Studio or Azure Data Studio, run, and it will create, and I'll show you. If I go to my monitoring queries here in my Management Studio, if I go to Programmability, Stored Procedures, you have the QPI multiple added stored procedures and functions and views. So lots of good information that KPI will give you, and you find the details on how to use this library on the link that you see there on my notebook. All right, another way of looking at this data is if I go to my portal and I go to my dashboard, I pin to my dashboard this Azure SQL Analytics, which is part of my OMS, the old OMS now called Log Analytics. So let me go to Log Analytics just to show you. So I have here my Log Analytics information, and I can go to my workspace summary, or I could go directly from the dashboard that takes me to this Azure SQL Analytics preview. This is a fantastic tool that allows you to see what's going on with a small delay. I believe we are now at 5 minutes delay in the time that anything happens, and you can see what's going on here. I may be wrong, it may be 15. We are constantly improving it, but I believe it's 5 now. So if I want to see CPU utilization, for example, and I click here, it takes me to my KQL queries that I can have. This one was created for me, but you can modify it, and you can, for example, instead of having a period of 30 minutes, I can make it 5 minutes. And this is similar to just this bin function. It's similar to an aggregation function, and it will give you intervals of 5 minutes instead of 30 if I want to see at that granularity, or maybe every 1 minute if I want to be very precise. And it will just give me the details on when the CPU was higher or lower. My MI is in UTC time, and this is showing me UTC time. And this is super important that you know if it's UTC or not, because when you see what was going on, I see here that my CPU was high, but what was causing this? So if I look here at 6:40 a.m., then I can go to my query store, which I had already configured in my specific database. Under the query store, I can see what was going on at that time, 6:40 a.m. Let me see if it was today or yesterday. 6:40 a.m. on the 10th. So it was today. So if I go back to my management studio, if I open any of these reports, so I'll just go to, sorry, not stored procedure, under query store. If I go to my, let's say, top resource consuming queries, and I want to see what was running at that specific time, I'll just minimize this and expand this report, and I'll look for configure, CPU time, max CPU time at that specific period. So on the 10th, so I'll put the 10th, from 6 a.m. or 6:30 a.m. to, we saw that it was at 6:40. So let's just go to 6:50 a.m. today, and this is important. Instead of local, UTC. Let's look at the top 25 queries, and when we apply, it will show us what query was running at that time. And sure enough, it was this query that I created just to create load, but it could be your query that caused that issue, that caused the call to the DBA at 10 p.m., for example. And you will see exactly what was going on by just following this pattern. Look at the consumption. After you look at the consumption, was it CPU? Was it IO reads? Or was it IO writes? Then you can use the DMVs that I showed you. You can use the portal metrics that I showed you as well, or you can use log analytics. Any of those can show you what was going on in regards to the resources. And then you come and you see at the specific time if it was CPU, if it was logical reads, if it was logical writes, or anything else that you see there on this list. And then you set the specific time, you find the culprit, and then you come and see the execution plan. Why was this causing this issue? Maybe we could improve this nested loop here. Maybe we could modify my query to look a bit better. So if I right click and I do, where's my query text? I have to go to the query itself, which is query number 81. And then if I click here, I can see the query text right there. I can copy this query, open a new query here, paste it there. I can then look at the query, see if I can improve it, write it in a better way that it will not cause so much issue, right? That's the same procedure you're used to do with SQL Server. Azure SQL Database, the same thing. Let me just show you in SQL Database how different it would be to do this. I have a SQL database under SQL servers, my Rocavalc server. In Azure SQL Database, you have this intelligent performance. You have this, where's my performance? I'm at the server level. Sorry, let me go to the database level. So if I go to my database, now I'm on SMCDB1, that's my database. Then I have this option here to use intelligence performance that I can see what was going on here on the portal at the query level. I can see that this yellow query here was consuming the most. If I click on it, it will tell me what was the query. And if I click on it, it tells me the query ID and it shows me the query text. We don't have that for MI yet. We're working on it. Hopefully soon we should have this same option, query performance insight. Note the name QPI that I showed you, the QPI DMV library. So we have QPI also in a graphical format for Azure SQL Database, but not for SQLDB, for MI. Okay, going back to my notebook, I have a few more things to show you here. If you want to monitor for I/O, I showed you that you would run this snapshot first, and then after you run this scenario, you run some workload. So let me run another workload and maybe another one, just as an example. And then after some time, when I query this QPI file stats, note, I hope you can see it. Sorry for the size, folks. Here's the snapshot file stats, and here's the file stats. So the file stats is for you to run after you have your workload. And then when you click there, it will query and see just the differences. If I had used more IO, it would show me here the read IOPS, the write IOPS. Similar to, here's another technique that I've learned and used many, many times with my customers. It's the same as right before you run a query. So let's run this query here. You add set statistics. On this one, I can make it bigger. So make it 150. Set statistics IO time. You could use XML as well to look at the query plan on, and then you repeat it down here and set it to off. That's a very, very useful technique to see what's going on when you run a query and you go to messages and you see the CPU time, elapsed time, and if this query like this one. Let me just give you a better example. If I just go to any table, let's say order detail, and I do select top 1000. If I do that same, if I use the same technique, and let me copy it again, off, and if I run this, execute, I can see under messages that there was a scan, 7 logical reads, no physical reads. If I remove the top 1000 and I read it all, and what I do is this: I copy this result and I save it up here just so I can compare it later on. So this is, you won't, well, you will believe me, but this is very, very helpful, and I was able to help people resolve issues just by using this technique here. So you see afterwards the number of rows that were read. This is a small table, only 542, so it only did the same one scan, and the time didn't change just because they were very similar. The other thing I do is this: I copy this and I put side by side, or one up, one down, and you can see quickly what's going on. So this tip is super valuable for many troubleshooting situations that you will encounter with SQL Server, Azure SQL Database, and with MI. And you can just use this to see how much impact you have on your IO subsystem or not. The DMVs that I showed you that are encapsulated here will give you excellent information as well. Same thing you can do with this technique, is to add a label. So when you add a label, as you run the snapshot, when you start the snapshot, you run your workload, and then you have another workload that you wanted to monitor. As you create those labels, you can then read them using this QPI file stat snapshots. This can be quite helpful. You see here the multiple labeled ones, and every time I ran this file stat snapshots. So I highly encourage you to use the QPI in your SQL MI environment. Get familiar with it. There are tons of different ways of troubleshooting performance with this library. So I highly encourage you to use that. And finally, the last one that I wanted to show you is with SQL MI, you have also the query store. Actually, that's not the last one. I saved another little nugget for the end. For those of you who are more experienced with SQL. I hope you like that. But before I show you the last thing, I will show you the query store. So with the query store, not the query store, extended events, you have live view of what's going on. I created this PSS Diagex event, and if I want to watch it live, it's showing me a few of the different fields that I asked it to show me: SQL text, the duration, what are the weights, and this is just a regular X events that you use in SQL Server. You can see it live in MI the same way you do with SQL Server. So you have your profiler in real time. So if you have situations where you want to see what's going on in real time, that's a great tool for doing that. And I don't know if you're familiar with it. You want to see what's the speed. So you just right click, show column in table, and then you can see what's the speed that's causing this. You can stop and you can aggregate all kinds of grouping. So very powerful tool, just like what you have in SQL Server, you have it here. And the last thing before we go to Q&A is in Data Studio, you have the capability of right-clicking and managing with an extension. I added this extension here. You can manage your MI and see it resource consumption in a graphical format. You can see the properties of the DB without even needing to run those DMVs that I showed you. You can see details about TempDB, your storage, and you can also get recommendations. So if you install this tool, it's a free tool, Azure Data Studio, just download, install it. There is I'll show you here, it's an extension that's installed here. It's called Manage Instance Dashboard, and it's made by Microsoft. So we put this together for you for free. You just download, install, and you see those details. And we have the documentation showing you the details on how to use it. And then for the folks who are used to SQL Profiler, that's the nugget that I wanted to show you. I installed this extension. And if I go to, let me go back to my server, right click my database. Sorry, I'm on the server, tables, launch profiler. Then you have I'll start the profiling, and you have your traditional SQL Server profiler, which you also have in SQL MI. Let me see if I'm in the right one. Standard view, T-SQL view. Yeah, the standard view was starting to capture data. So here we go. My SQL batch is coming from my old stress application that you saw here in my PowerShell, and it's capturing all the details just like you've always done with SQL Server using Profiler. In MI, you have Profiler as well, so you just need to use the SQL Server Profiler. Extended events is much more powerful than the old profiler. So I wouldn't suggest you use profiler in SSMS, but if you want to play with this profiler here, it's not as heavy on data manipulation. It's just not as heavy on your machine. So these were the points that I wanted to cover with you. There are tons of things that you can do with these tools that I showed you. Again, if you have any questions about any of the tools that I showed you here, any of the techniques, feel free to contact me. You have my email address and my contact information, and I'll be glad to answer. So let's go to live Q&A. What can I help with information today?
Sure. So we've got a couple questions in here already. And so somebody was they're looking for a reference to sysdm user DB resource governor internal. Is that an Azure only DMV?
It is. It's Azure only DMV. And I believe it's only MI. I don't think it works with SQLDB.
Okay. And then somebody else says, I've had issues where SQL MI becomes unavailable for seconds to minutes. Microsoft says that it's a planned failover for them to run updates. Is there any way that they can get information about planned updates and other information about these types of planned outages?
Yes. So that has been one of the major concerns for many folks who migrate to SQLDB and MI for as far as I can remember. I've been supporting SQLDB since 2010. It's been 10 years. And we finally gotten into a system where I believe it's in preview right now, where you will be you receive a notice of when we are planning to update your specific cluster. But this is
Okay.
only valid for the moment when we are going to do it for you. The problem and the reason why all these years we never had anything like that, this advance notice, is because the system was designed to self-heal. It will take just a few seconds for the failover to happen if it is a business critical machine, because it's implementing something similar to always on availability groups on the back end, with 3 machines always ready to just take over from one another. But if you're on a general purpose like the one that I am using right now, it will take a bit longer, because it works kind of like a failover cluster. So the failover time takes a bit longer, and it will actually, we will spun up a container with a new instance of SQL in there. So that's why it takes a bit longer, but it's also up to 30 seconds. So those can happen at any time. We won't be able to tell you in advance, because they may happen because your node is broken, the hardware is broken, the software is broken, something is broken that in order to fix it, we fail over automatically. It's all done by bot. And so, yes, very helpful to know when we are going to do it, but it may not be enough for the other situations, the self-healing.
All right. And then for the link for QPI, is that at https github.com/jokapc/QPI?
Let's double check. I have it here on my notebook. On my notebook here, the link says, yes, that's exactly it.
All right. Excellent. And then a gentleman that joined late asked, what is the advantage of using SQL MI versus Azure SQL database?
Closer compatibility to SQL Server. If you have a on-premises SQL Server and you want to migrate to a PaaS service, MI will be easier to do. We recommend you go to SQLDB as much as you can for newer developments. It can give you better flexibility than MI can. But there are multiple reasons why people prefer to go to MI instead of SQLDB, and vice versa.
Right. Excellent. Well, those are all the questions that we have today. Thank you for the presentation. Thank you, everyone, for attending. This has been excellent information. And I look forward to having you come back and do another presentation in the future.
Sounds good. Thank you so much for having me.
Oh, absolutely. And thanks, everyone, and have a great rest of your day.
All right. Bye-bye.